everyone, this is Maurizio, editor-in-chief of Power Electronics News, and today we are at PCIM, and I have the pleasure to stay here with Dries, General Manager of Qorvo Power Device Solutions. Hi Chris, how are you?
Good, how are you, Maurizio? Thanks for having me.
Thanks a lot for coming on. So we are at PCIM, a lot of news, so what Qorvo is showing, is introducing. Tell me more about Qorvo.
Well, I think the first big news is Qorvo's presence here as a power business. You know, most people know Qorvo as a mobile products RF company, and since 2019, Qorvo really began investing in power, first with the Active Semi acquisition in 2019, then the acquisition of our business, United Silicon Carbide, in 2021. And so first, you know, presenting Qorvo as a real force in power is a big part of the show here. But the other really interesting thing that's gotten a lot of traction here at the show, it's really exciting, is a new power simulator called QSpice. So a lot of people are familiar with SPICE simulators. This is the most sophisticated SPICE simulator that's out there now. Sampling in limited quantities, but you know we'll be releasing it very shortly, and I think a lot of power designers are just going to love what they see in that product.
Power designers will love this QS Spice for sure. So, talking about United Silicon Carbide, the addition of United Silicon Carbide portfolio to Qorvo has expanded the application in high power in particular. Just talking about silicon carbide, so the automotive is moving towards silicon carbide. So the semiconductor industry is seeing a big shift in terms of wide band gap. So talking about silicon carbide, how do you see the market for silicon carbide power semiconductors evolving in the next few years?
Well, I think we're continually displacing silicon right now is what's happening. You know, I think as any new designs are taking place, typically with silicon carbide, we have one solar inverter customer, for example, who a year ago, when they were asked, you know, what new designs are you going to use silicon carbide in? They said, we're using silicon carbide in all of our new designs. And you know, we're in actually a really good position with our Cascode FETs to help in replacing those silicon FETs. We constantly see super junction customers come to us because we have a standard gate drive to simply replace those CoolMOS FETs or super junction FETs, excuse me, with our FETs. The other thing that's changing are topologies. You know, the wide bandgap devices are enabling new types of topologies like totem pole PFC to be implemented much more easily. So it's just a constant shift from traditional silicon, superjunction, IGBTs into silicon carbide.
A topic that I would like to talk with you is climate change. So following the demand, the climate change demand, innovation is important, so will play an important role. In general, innovation is important. What's innovation for you? And in particular, in power electronics, which are the latest innovations that you would highlight, and how power electronics would contribute to the climate change, just to reducing the impact of climate change?
Yeah, so there's actually a famous Princeton paper out of Princeton University called the Wedges paper about, you know, how to get to a sustainable path on CO2. And it incorporates sort of like 7 different things. Like not just one thing alone is not going to solve the climate change problem. And I sort of think about power electronics as a piece of one of those wedges. You know, one of those is that they call out as renewables. Well, power electronics is a key element in you know, enabling, you know, higher efficiency solar inverters, enabling energy storage, the electrification of vehicles. Power electronics is at the heart of all of that. And so it's a combination of conservation, you know, doing more with less. And in fact, actually for United SiC and now Qorvo, we do that even when it comes to the raw material itself. You know, so we use at 1200 volts, 1/2 of the silicon carbide that you need to achieve a particular current rating compared to the competition, and 1/3 of the silicon carbide at 650 volts. So when you consider the cost of growing a silicon carbide boule, we're saving an enormous amount of raw material in our implementation.
And in all of this, we need professionals, we need engineers. So there are a lot of career opportunities in the field of power electronics. How do you see this new job, if we can say new job, how students, young professionals can prepare themselves for these rules, these next rules also. In particular, maybe university, industry should work together, maybe close the gap that we see.
Well, I think the nice thing about power electronics in our industry more largely is that it spans many different disciplines. So if you think about the raw material side, it's material science, it's chemistry. When you think about power electronics design, it's electrical engineering, it's mechanical engineering, it's coding and software. So anyone in these STEM fields has a role to play in power electronics.
So a lot of opportunities for engineers. Thank you, Chris. Thanks a lot for joining us.
Thanks for having me, Maurizio.
And thank you for your time. Stay tuned to our channel, powerelectronicsnews.com, for the latest updates. Thank you.